Good morning. Today's my lecture topic is Foundry. This is coming under the basic civil and mechanical engineering. Actually, if you given the definition for foundry is a manufacturing facility where metals are melted and poured into molds to produce castings of desired shapes and sizes. The raw materials, the main materials used in foundries are metals like cast iron, steel, aluminum or bronze, and molding materials such as sand, clay and binders. Next one is pattern making. Patterns are replicas of the final casting used to create the cavity in the mold. They are usually made from wood, metal or plastic. Next one is molding. The process of preparing the mold cavity using pattern and molding sand. It includes scope, top part and bottom part sections. Next one is core making. Cores are used to form hollow sections or internal cavities in castings. They are made from core sand mixed with binders. Melting. Metals are melted in furnaces such as cupola, induction or crucible furnaces depending on the metal type and quantity. Pouring. The molten metal is carefully poured into the prepared mold through a gating system to fill the cavity. Solidification and cooling. The molten metal cools and solidifies inside the mold, taking the shape of the cavity. Cooling rate affects the grain structure and properties. Shakeout and cleaning. Once solidified, the mold is broken and the casting is cleaned by removing sand, gates, risers and other impurities. Inspection and finishing. The final castings are checked for defects, dimensions and surface finish. Defective castings are either reworked or remelted for use. Next one is based on type of metal cast. The foundries are classified as ferrous foundries, non-ferrous foundries. Ferrous foundries include casting iron and steel. Non-ferrous foundries include casting aluminum, copper, bronze, zinc, etc. Ferrous foundries. These foundries deal with the ferrous metals such as cast iron, ductile iron and steel. Example, iron foundries and steel foundries. In non-ferrous foundries, these handle non-ferrous metals like aluminum, brass, bronze and magnesium, which are lighter and corrosion resistant. Based on production type, the jobbing foundry produces small quantities or custom castings as per customers' requirements suitable for repair or procurement. Production foundry produces standard casting in medium or large quantities, common in automotive and machinery industries. Based on molding process, it is further classified into sand foundries, permanent mold foundries and die casting foundries. Sand foundry, the most common type, uses sand as the mold material suitable for large and complex shapes. In die casting foundry, uses metal molds and applies pressure to inject molten metal, ideal for mass production of small precise components. Investing casting or precision foundry produces high accuracy, fine surfaced castings using wax patterns and ceramic molds used in aerospace and jewelry industries. Next one is the important topic is pattern making. Here the process starts with creating a pattern which is the exact replica of the part of the cast. It is used to make the cavity in the mold. Molding. Molding involves preparing the mold cavity using sand and the pattern. It consists of two parts. It is top and bottom. In core making, when the casting requires hollow sections or internal cavities, cores are made separately and placed inside the mold. Mold assembly. The mold halves are assembled and cores are positioned properly. The gating and the riser system are also fixed to allow smooth and metal flow. Melting of metal. The required metal or alloy is melted in furnaces such as cupola, induction or crucible furnace depending on the material. Pouring. The molten metal is poured into the mold cavity through the gating system carefully to avoid turbulence and defects. Next one is solidification and cooling. The molten metal cools the solidifies in the mold, taking the desired shape of the pattern. Cooling rate affects the strength and the grain structure. Next one is cleaning and fitting. The casting is cleaned by removing excess sand, runners, risers and surface impurities. Curing and polishing may be done for smoothing. Next one is inspection and testing. The final casting is checked for dimensional accuracy, surface quality and internal defects using methods like visual inspection, ultrasonic testing or radiography. By giving final inspection, we are manufacturing the required mold. Thank you.